Let's do a tracing example with structure types. I've made up a structure type called time, which will store an hour and minute. And I've tried to keep the names short enough that drawing them on the diagram won't be painful. I have two functions here. One of them takes a time object. The other one takes a pointer to a time object. And part of this tracing example, I want to foreshadow a notational thing we're going to want to talk about a bit later. And then down in main, I make two variables of type time. They're called p and q. I set p to be 6 and 10 initially, q to be 17 and 11. And then I try calling my functions and they generate some output. Okay, so let's start our trace. I'm going to strategically make my diagram for main a bit more vertical than usual. There we go. And I'll even make myself a little space down here for the output when the time comes. Okay, so in main, the first thing I do is I create a variable p of type time. So there's p, it has type time. And it contains, as its two members, the member called hour, which is set to 6, it's an int, and the member called minute, or min, which is also an int, which is set to 10. All right, next thing I do is I create another variable of type time called q. And it contains, its hour is set to 17, and its minute is set to 11. And they are both ints. All right, so this represents the state of my program at this point. Notice that p and q are both of type time. Sure, there are things inside of them that are ints, but p itself is of type time. The reason this is so significant, especially when we're working with pointers, is that we need to be able to resolve things like, can we assign this value to this particular pointer type? Okay, so then we hit line 31. And a very common misconception at this point in the course, because we've just come off of a month of talking about arrays and pointers, and in particular that weird thing with arrays where their name behaves like a pointer, is it's really easy to forget that most variables, when you pass them into the function, are a straight up copy is made before being passed. Now, I was careful during the array section of the course to make it clear that rule isn't being violated with arrays. It's just that the name of an array doesn't mean what we think it does. That the name of an array functionally is a pointer. So here I'm calling my function f. And notice that my function f, the type of its argument is type time. So let's draw that out on our diagram before we even pass in the argument. All right, so actually I'm going to clean this up a bit. There we go. It's got a variable t of type time, and it will contain, as it is supposed to, a member called hour and a member called minute. All right, and they're both ints. Okay, so I have now set up my variable t on the diagram. What gets passed in? Well, the argument to the function f is the value of p. In main, p is this. So what gets passed in is going to be a photocopy of p. So I take each member of p and I copy it in to the corresponding member of t. So t would now contain this. Okay, we've set up the arguments to the function. We're now ready to execute the function. Line 14. So I'm in this scope now. Line 14. Go into, so the left-hand side is in the variable t, access with the dot operator, the member called hour. Remember that you can only use the dot operator if the thing on the left of the dot, in this case t, is of a structure type. And in this case, yes, we look inside the variable t, it does have members so we can access them. So set the member called hour to be 0. Then set the member called, the member is just called min. Set the member called min to also be 0. And if you're tracing with a diagram, it should be pretty obvious to you by line 16 that the thing that I modified to set to 0 is just a copy that's owned by f. The original in main is safe. It doesn't get changed. By the usual rules of scope and the way we pass arguments, we pass them by value, something that we understood in September. That isn't any different for structure types as it would be for ints and floats. So then, as of line number 16, this function ends. And that's the end of that. So that modification basically did nothing. Okay, the function ends, the scope is gone. Okay, we go back down to main and we generate some output. And we print out, let's see, p equals and then we print out p dot hour would be 6, and then p dot minute would be print out the minute in 2 digits, so 610, and then q, comma, q equals, let's see, 17:11. All right. And remember, if you ever have to do a tracing question that involves generating actual output, we won't worry about the %02 thing. That's just for formatting. Okay, line 34. So I've generated my output on line 32. Now line 34. Line 34 calls the function g. So let's draw the scoping box for, that's a 6. Let's draw the scoping box for the function g. There it is. What does g have as its argument? It has a single value called ptr of type time star. So remember that I can make a pointer to any type, just like I can make an array of any type. I could make an array of time objects. I can make a pointer to a time object. But fundamentally, if you have a pointer with a single star in its type, it is an arrow. That is it. It is an arrow that points to an object of type time. So the box that I draw in the diagram is a box big enough for an arrow, not a box big enough to contain the members, because it doesn't. It's just a pointer. So what do I pass in? I pass in arrow pointing at Q in the scope of main. In the scope of main, Q is of type time, which means arrow pointing at Q will be of type time star, which means I can pass an arrow pointing at Q as an argument of type time star. So what does G get? G receives this arrow. In the context of my diagram, notice that the arrow points at the big outside box for Q. So the arrow that I'm following here points to all of this thing, not to any particular member. You could, if you wanted to, make a pointer to just the hour component, and you'll find that's very useful on assignment 6. But you can also make a pointer to the entire object, the entire structure contained in Q. Okay, so then I call the function g. I've set up all the arguments to g. I'm now ready to begin executing it. Line 18, this is a bit weird. So I've got a dereference inside brackets with a dot applied to it. Let's just meditate on this for a minute. Can I write this? So could I use the dot operator on the variable ptr? And I mentioned in previous videos, you are allowed to use the dot only if the thing on the left is a structure. Is this a structure? No, it isn't. It's true that I could use it to get to one, but this by itself is not a structure. I can't use the dot on it. There is nothing inside here called hour. So line 18, as I've written it, is an error. What about what I have now? Star PTR all in brackets. So what does this mean? Well, based on the brackets, and it turns out you have to have the brackets if you want to do it this way. You cannot, if I delete the brackets, what I'm actually saying, if you look at the precedence table, is this. So without the brackets, the dot operator has higher precedence than the star. So if I want to do what I'm doing here, I have to use the brackets around the star operator. What this is saying is start at the pointer, PTR, follow the arrow, and then wherever you end up, go into that thing and get me the member called hour. So let's act that out. Start at the pointer, follow the arrow, that takes me to this box here, and then go into that and give me the member called hour. Okay, there it is. So I have to first follow the arrow if I want to use the dot operator here. But I am allowed to do that. So follow the arrow, set the member hour to 9. Okay, line 19, follow the arrow, set the member called minute to 9. And notice that in typical form, based on the way we've been using pointers all semester, this allows us to modify the original structure in main, which is nice. But you might also realize if we're going to be using a lot of structures in our programs, this is going to get a bit tedious because we are often going to want to throw around pointers to our structures for a lot of reasons, one of which is I want somebody to modify them. Another reason is it might be even if I don't want them to modify it, the structure is so big, it's so full of data that passing around copies would be time consuming. Eventually, maybe my structure has 1 million things inside it. I don't want to make a copy of 1 million things. If instead I pass a pointer, the pointer is pretty lightweight, so maybe I'll use that instead. In any case, it turns out we very often end up with pointers to structure objects. And then that means I very often want to both follow the arrow and get a member in the same operation. And this is a bit cumbersome because of the brackets, the need for those brackets. And it turns out I might actually even have multiple layers of brackets, and that can get really ugly. And so the C language defines some syntactic sugar, the arrow operator. And I will talk about this more in the notes, but basically the arrow operator is exactly the same as the star and the dot. Just like how plus equals can be simplified. If I write something like I plus equals 1, that's the same as writing I equals I plus 1. It is just syntactic sugar. And it's up to you whether you use it, but you should be prepared to read code that looks like this. So when I use the dot operator, the thing on the left of the dot must actually be a structure. When I use the arrow operator, the thing on the left of the arrow must be a pointer to a structure. So you can't use the arrow directly on the structure object, and you can't use the dot directly on the pointer. But the arrow is a combination of follow the pointer and then access a member. And you'll discover it is pretty convenient. But we'll leave that point because for now, let's focus on finishing our trace. So we get down to the end of line 24, and then the function g ends. So of course, it's gone, and we will just wipe it out here. There we go. And then I'll just touch this up. There we are. And we end up back at the end of line 34. There is no return value here. Okay, so I print out the values of P and Q again. So P equals, well, it's still equal to 610, and Q equals 909. So because of that %02D, the minute gets printed out in 2 digits, whether it actually is a 2-digit number or not. All right, so that's my trace, and then main is over, but let's try running this code. So we'll compile it, we'll run it, and there we go, we get that output. And just to demonstrate, let's take a look at what happens if I replace my dot and star construction with my arrow operator. So the arrow operator can only be used on pointers. It is just syntactic sugar because it turns out that pointers to structure objects are very common. And what the arrow is saying is take the thing on the left, follow one arrow from it, and then go get me the member call to hour. And it'll give an error for all the reasons you'd expect the dot operator to do. For example, if there is no member called hour, or of course, if the thing on the left isn't a pointer to some kind of structure. So we'll try running that, and we see it gets exactly the same output.